Welcome to Digital VLSI Design Virtual Lab, experiment number 5, 4x1 multiplexer. The aim of this experiment is to design and plot the characteristics of a 4x1 digital multiplexer using pass transistor and transmission gate logic. Now to begin, click on the Simulator tab. Two separate links are provided here, one corresponding to a 4x1 pass transistor mux and the other corresponds to 4x1 transmission gate mux. We will now look at the operation of a 4x1 transmission gate mux by clicking on link number 2. In this new page, you have the schematic diagram of the circuit setup for a 4x1 mux on the left side of the page and ngSpice program on the right side of the page. N2, N3, N4, N5 are the 4 data input lines for the 4x1 mux, whereas N12 is the output line. N6 and N7 are the only two selection inputs, whose inverted version are N8 and N9. This is implemented by separate inverter circuits as shown in the lower part of the diagram. On the right side of the diagram, you are given the details of a 2x1 mux, which has two inputs N2 and N3 and a single output N6. N4 is the only one select input, whose inverted version is N5. This 2x1 mux is implemented by using two transmission gates, 1 and 2. Each of a transmission gate consists of a pair of PMOS and NMOS devices. All of these inner interconnections inside a 2x1 mux are captured in the dot subcircuit subroutine labeled as 2x1, whereas N2 and N3 are the input lines, N4 is the select input whose inverted version is N5, and N6 is the output. N1 is the high voltage state to which the PMOS device bulk should be connected. Similarly, a dot subcircuit subroutine is also written for an inverter circuit whose input is N2, output is N3, and N1 is the static power supply. The connections are similar to what we have seen in experiment number 2. Then the ngSpice program defines the interconnection of these various subcomponents. Here VC is the DC power supply of 1.8 volt, V in 3 to V in 0 are the 4 input data lines, which are defined as pulse waveforms having different frequencies. For example, V in 0 is a low frequency pulse waveform of pulse period 40 nanosecond, whereas V in 3 has a pulse period of 10 nanosecond and it corresponds to high frequency signal. The inverted version of the select inputs are constructed by using two separate inverter, X in 0 and X in 1. Finally, the interconnection of the three 2-input muxes to form a 4x1 muxes are shown in the next 3 lines. Afterward, the SPICE level 49 model for PMOS and NMOS device are specified. Finally, this program ends with a transient analysis command which runs the program for 350 nanosecond. In order to plot the outputs, click on the Simulate tab. It may take a while for the waveforms to be plotted on the interface page. The first 4 waveforms corresponds to the data line input. The waveforms are plotted in the following order: V in 3, then V in 2, V in 1, and finally V in 0, which is followed by 2 data selection inputs, S0 and S1. The MSB is shown below. and the LSB is shown above. Finally, the output of a 4x1 multiplexer is plotted. For a data selection input 1 1, you have the high frequency data input selected to the output. For a data selection input 0 0, which is coming at around 250 nanosecond, the lower frequency line or Vin0 is selected. Similarly, one can verify various combinations of data input lines and select input lines by varying the pulse waveform in the SPICE code. As we have done in the previous experiments, one can also perform a timing analysis by appropriately magnifying the time scale of the output plot and measuring the rise and fall and the propagation delay of the pulse. In the similar manner, one can also perform a pass transistor logic based implementation of a 4x1 mux by clicking on link number 1 in the simulator tab. Thank you.